Okay, so today we are solving a system of equations. And how do I solve a system of equations? I gave you a brief little a prequel to what we would be doing. What are we doing to solve our system? Anybody say what we just did? Yep.
Graph the lines and find the point of intersection.
Graph the lines and find the point of intersection. A solution to a system is the point of intersection. Okay? So today we are learning to solve by graphing. Tomorrow we'll learn to solve the system of equations by substitution. And the day after that we will learn how to solve by substitution by elimination or addition method. Okay? There's multiple ways. The graphing method is the least favorite. Okay? The graphing method is the least favorite. So, the first thing you're going to do is, this means they want you to use both of these equations. It's just the way they're listing it. Okay? So you're going to separate your equations. I usually like them separated with the graph in the middle. It doesn't mean that I won't take them next to each other, but you better put space between them. Now, the easiest way to graph is what method? Slope-intercept. So, the first thing I'm going to do is identify on the first equation. I must write it. Don't just go from up here. Okay? You're going to write the equation. And there, right under it, you have to identify two things that are important. What are they?
Slope and intersection.
The m is 2, and the b is -1. And we're going to graph there. So my b is -1. And I'm going to do what? I'm going to rise how much? 2 units and run to the right. Good. I'm going to rise 1, run 1. Rise 1, run 1. Or I could do -2, -1, because a negative divided by a negative is a positive. So I can go down 2 over 1, down 2 over 1. You with me? And then I'm going to connect my points. Same thing. Remember I told you no more than one one line per graph? Well, I lied. We're in systems now. It's 2 lines that have a relationship. Or 3, the point of intersection, the solution. And now I'm going to take the other equation. I need to get y alone first before I can find the slope and the y-intercept. Chloe, what do I need to do?
You need to then translate it from standard form into slope-intercept form.
So what do I have to do?
You need to subtract x.
Subtract x from both sides.
And then you get y equals -x plus 5.
What's my m, Nicole?
-1.
And my b?
5.
Good. Okay, so where do I start? Where am I starting? Brianna?
0, 5.
Let's start on the first one. Oh, yeah, 0. Oh, sorry, we already did the first one. Let's start at 5. Where is that at? 0, 5?
It would be
On the
on the y.
axis, right? We're going to 5 or 0, 5 on the y-axis. And then I'm going to rise how much?
-1.
Down 1, and then
1.
right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. Now, the point of intersection of the 2 lines, what is it? 2, comma 3. That is the solution to the system. Okay? That is the solution to the system. Pause the recording if you need to keep taking notes. All right, so for the next one, I'd like you guys to try and do it on your own. Now remember, please separate your equations. Don't let one run into. Don't start your equation here. Rewrite it. Get y alone. And then don't forget about your negatives. Pause the recording, and I want you to find y alone and then graph each line and find the system, the solution to the system. But I didn't get to the front rows, but Noah, what solution did you get?
I got -2, 1.
Agree or disagree? Agree. So, one of them, I couldn't figure it out because she was graphing so perfectly. So, I went back, I even checked her work, and then it turned out we wrote the problem wrong. So always go back to that. How did I check? I checked with my B, and I noticed my B was a -1, right? And then I realized that you just had to move this X over, and so it always started out as a -1. So that's when I realized we had, so I'm starting at -1, and then I'm rising 1, and I'm running -1. Or I'm going to rise -1, run +1, run -1, +1. Okay, on the other one, we're adding X, divide by 2. Nicole, what is my M, what is my B?
Oh, your M is in half and your B is 2.
Good, so I'm starting at the 2, at the +2.
I put my M as 2.
Okay, do you understand why it's 1/2? Because it's divide by 2, divide by 2. It's not 2, there's a 1 here that we don't naturally see. So it's really a 1/2. So now I'm starting at 2, I'm going to rise 1, run 2. Rise 1, run 2. Or I can go -1, -2. -1, -2. You got that? So now the solution that we got, one more time, Noah, is what?
-2, 1.
-2, 1 is the solution to the system. Okay, questions there? This also means that whatever the solution is should work in the equation and make both sides equivalent. So, when given the question like this, determine whether the point is a solution. I'm going to take the original equation and I'm going to substitute in. 3 times what? 2 minus 1 equals 5. 6 minus 1 equals 5. 6 minus 1 is 5. 5 equals 5. So is this a solution to this equation? Yes. Okay, I'm going to try it again. 2x plus y equals 10. 2 times what?
2.
2 plus 1 equals 10. 4 plus 1 equals 10. 5 equals 10? No. So we would say it's not a solution. 2, 1 is not a solution to the system. Of equations. Okay? Is this making sense? Okay, I want you to pause it and try number 2. Go. All right, so when I substitute x minus 3y equals 7, Nicole, what am I substituting in?
You're substituting in 4 for the x.
4 minus
3 times -1 equals 7.
-1, sorry. Equals 7. So 4 times what? 4.
Minus -3. 4 minus 3.
No, it's not 4 minus 3. It's a double negative, and it's multiplication. So it's 4, and it's 3 minus 3 times -1. It's multiplication. We do multiplication first. So what does it become?
4 minus -3.
Minus -3 times -1 is what? Positive 3 equals 7. 7 equals 7. Okay, it works there. Next one, -x plus 2y equals -6. What am I substituting? And you need to show every level of this substitution. It's really on my nerves that you're just starting with numbers. Substitute into the problem. Julia, what am I writing?
-4
Plus,
plus 2 times -1.
okay, and that simplifies to negative,
-6.
no, -4.
-4 plus -2.
minus 2 equals negative 6. Negative 6 equals negative 6. So what do we say? Yes, it's a solution to the system. Okay, so remember I said to you, this is like not the favorite method. First of all, it's time consuming. And secondly, this is the reason why. Graph this problem. What's the issue here? It's in between boxes, so we can't get an exact location, and there's no way, there is absolutely no way to estimate it. We can say the point is close to 4.5, comma negative 1, but it's not at it. Does that make sense? And that's why we use substitution and elimination. All right? All right, let's look at one word problem before we go. I have Pam has 120 and is spending $5 every week. What are my unknowns? What's the depender? What's independent?
Money and
Oh, how much she's spending.
Money, what'd you say?
the money is independent.
Money is not independent. Yes.
The money spent and the money saved is independent.
Nope. Let's first talk about what's my unknown here. What's changing?
The amount of money she has.
Yes.
The amount of money he spent.
Nope. What? The week. So let's call that X. Weeks are changing. And weeks, depending on how much I'm spending or how much, depends on what overall money in the account. So that would be my Y. So what would the first one be? Money in the account is equal to, no, money in the account is not 120 because it's changing. Money in the account is equal to what? What's starting point? Nobody knows what the starting point is for Pam? 120. She's starting with 120. So Y equals 120, but how would I show is spending $5 per week? Yes.
Minus 5x.
Minus 5x. You got that? And what would Lorenzo be? Money in the bank is, what would that look like, that equation? Julia.
Y equals 20 plus 750x.
Perfect. Right? Okay. So if X is weeks, that's going down here, and Y is money. It's going on the Y axis. Remember, the total money in my account depends on how many weeks have passed. Okay? The time that's passed. So I can make a table. Instead of going by week 1, let's go by week 2 because this is like an awkward number. So at 0 weeks, how much does Pam have? 120. But after 2 weeks, what does she have?
150. No, sorry. 115.
2 weeks, 110.
2 weeks.
Okay? Because that's 120 minus 10. After 4 weeks, what do we have? After 5 weeks, what do we have? Can we predict what she would have after 8 weeks?
Yes.
How much?
80.
And at 10? 70. And we plot those points. Now notice, is this a positive slope or a negative slope?
Negative.
Money starts high and I'm losing it. Okay, next one. I'm starting at 0 weeks. What does she have? $20. After 2 weeks, 2 times 7.5? 15 and 20 is? 35, right. And after 4 weeks, 15, 30, it'll be $50. Can we figure out what would be next without using the equation? What would it be? 80. And then? 95. And we plot the points. So the question for this system is, when will they have the same amount of money? When will they have the same amount of money? In week 8, they will have how much?
$80.
$80. In week 8, they will have $80. In 8 weeks, they will have the same amount of money, $80. Does that make sense? Okay, so today, what was the purpose of the lesson?
Solve system of equations by graphing.
Okay, how do I solve, what is the solution to a system? Gracie, go.
Solution is the point of intersection.
It's the point of intersection. If given two equations, what does it mean to be a solution? If given two equations, what does it mean to be an equation? Yes.
It means you can substitute the x and the y for both of them, and both statements will be true.
Both statements will be true. So again, last time, the purpose of this lesson is to learn how to solve a system by graphing. We look at the point of intersection, and that tells us our solution. That's it.